Welcome to this episode of Eureka. We are going to have a very interesting conversation with a person who has played with more than 40 cyclones in about last 10 years. Yes, that's Dr. Mrutyunjay Mohapatra, who is the head of Cyclone Warning Division of India Meteorological Department. Before we start our interesting conversation, let's take a brief look at his profile.
Dr. Mrutyunjay Mohapatra is known as the Cyclone Man of India. Currently, he heads the Cyclone Division in the Indian Meteorological Department in New Delhi. Dr. Mohapatra obtained his PhD in physics from Utkal University and has more than 23 years of experience in weather forecasting. He extensively contributed to modernizing and improving early warning services of the IMD, especially in the area of cyclone warning services. Effective early warnings of Cyclone Fallon, Hudhud and Vardha by his team have saved many lives. Dr. Mohapatra received many national and international awards. Noted among them are the Young Scientist Award of Ministry of Earth Sciences and Achievers Award from the IMD for his research and service in the field of atmospheric sciences.
Thank you for being with us.
Thank you.
Let me start with a very simple question. How does a cyclone get formed? After all, we have seen heavy winds blowing. Sometimes there is no wind. But what is the cyclone? How does it form?
If you just look at the word cyclone, it has been derived from the Greek word cyclos, which means the coiling of a snake. And you will be happy to know that this terminology of cyclone was coined during the British era by the British India, by the Henry Paddington, who was a rapporteur at Calcutta. Based on the observations from the ships flying over Bay of Bengal and Arabian Sea, he could estimate that winds in a cyclone rotate in anti-clockwise directions, like a coiling of a snake, hence the name cyclones. And this cyclone is a byproduct of the interaction between land, ocean and atmospheric processes. These cyclones does not develop just like a bolt from the blue. They develop from a low pressure system. These low pressure systems develop because of the intense heating of the ocean. If you just look at the emblem of India Meteorological Department, it states Adityat Jayate Brishti. That means sun creates rain. If I just explain you, because of the sun, the sea surface gets heated. And because of heating, the water particle gets evaporated. And this water vapor is released into the atmosphere. This water vapor is lighter than the dry air. As a result, the moist air is lighter compared to the surrounding dry air. When this moist air is released to the atmosphere, because of the instability condition in the atmosphere, it goes up and off, and because of its lighter conditions. As a result, the convection leads to the development of the clouds. With the formation of the clouds, there will be release of latent heat in the middle troposphere. And this release of latent heat again leads to warming of the environment. As a result, this moist air parcel goes again up and off. So by this process, the convective cloud mass, which develops over the tropical region because of the intense heating, becomes deepened and deepened. One cloud mass leads to another cloud mass, and hence a cluster of cloud mass is developed. These clusters sometimes lead to another clusters. So there will be merging of number of clusters. Development of these clusters leads to the development of a vacuum at the surface over the sea. And this vacuum area, in terms of the weight of the air column, which is popularly measured by the atmospheric pressure, will lead to the formation of a low pressure area. If all these favorable conditions, like intense heating of the sea surface, the instability in the atmosphere, and there is lower level convergence of the moist air and upper level divergence, and hence the rotational force in the atmosphere, then this low pressure area will gradually become a depression or subsequently a cyclonic storm. This cyclonic
So
storms,
it's basically like, for example, from a seed you get a tree. it's from some simple phenomena like, for example, the surface of the sea getting heated by sun that leads perhaps, in a kind of a cascading fashion into a cyclone. That's what you are saying, right?
Yes.
Yeah. Okay. I have a very interesting question. I think many of us, wonder always about it. Every 30 day, you have a full moon. Even a very complex phenomena like, say, for example, solar eclipse, you can predict much in advance. Why can't we predict a cyclone?
If you compare these two sets of systems, the previous one, like the astronomical features like lunar eclipse, solar eclipse, they are based on the linear processes mostly. Whereas the atmospheric processes like tropical cyclones, which develop over the tropical waters, are basically governed by the nonlinear processes. Here, the atmosphere, ocean, and land interact with each other non-linearly.
Very interesting. You use two words. One is linearity, the other is non-linearity. What do they mean?
If I just give an example, if you draw a straight line of 2 centimeter,
Okay.
then again you add another straight line of 2 centimeter.
Like this. I have a 2 centimeter, then I add
then
another
again
2
2 centimeter. Then it becomes total 2 plus 2, 4
Yeah,
centimeters.
4 centimeter straight line.
Straight line.
Yeah.
But if I draw a curved line of 2 centimeter, another curved line of 2 centimeter, and if I want to measure the distance between the initial point and the final point, it will not become 4 centimeters.
Yeah, because if the two curves are like that, that will be different. If the two curves are like this,
Yes.
it will be different.
Yes.
So it will become different.
So
Okay,
because
yeah.
these two lines, the curved lines, are non-linear. They are not the straight lines. So perhaps this is the best
Simplest
resemblance
example,
to explain the non-linear interaction within the different forces which act upon, as I discussed with you, for the development of the cyclones.
You are explaining that phenomena like, for example, cyclone are non-linear, whereas a phenomena like, for example, eclipse are linear. Even if they occur, over a long duration, etc., they are linear, so it can be predictable. But whereas a phenomena like cyclone is unpredictable. Is it really unpredictable? Meaning that we can't do anything about it?
Yeah, it is not unpredictable. It is predictable, and it is being predicted worldwide at present. Over the years, the difficulty in prediction of cyclones have decreased.
Okay.
If you consider North Indian Ocean, that includes Bay of Bengal and Arabian Sea, we have also been able to demonstrate the capability of India to predict well in advance the genesis of tropical cyclones, its track, its intensity, expected landfall point and time, and associated adverse weather like heavy rainfall, wind speed, and the storm surge or tidal wave.
That's
along the
interesting.
coast.
But then how do you do that? What's the magic wands that you have for making, let's say, a reasonable prediction about whether a cyclone will be formed or whether the cyclone will move in which direction, where will it have a landfall, and how do you do this?
And the tropical cyclone forecasting is basically governed by a two-way process.
Okay.
The detection of tropical cyclone itself is the beginning of prediction of the tropical cyclones. As you know, the cyclone develops over the sea areas, which is basically a data sparse region. It is more data sparse if you consider our ocean basin like Bay of Bengal and Arabian Sea, unlike the North Atlantic, where you have got the aircraft reconnaissance. For each cyclone or Atlantic, there is aircraft reconnaissance to take observations on the spot. Whereas in our ocean basin, we don't have that type of facility. But however, we have got a lot of observations based on the remotely sensed satellite tools and radars. And of course, we have got the observations from the floating buoys over the sea surface and the ships and coastal stations and island stations.
Okay.
So if I just want to say the prediction of tropical cyclone, it is an initial value problem. So if you can have the better estimation of the initial status of the atmosphere, land and ocean, it can lead to a better forecast.
Okay.
That is the basic hypothesis of any numerical weather predictions. As I was telling, the weather forecasting is a non-linear process. So therefore, it cannot be solved by any exact method. So we have to go by the numerical solution of the set of mathematical equations which govern the physics of formation of the cyclones.
Okay.
To solve these equations, we utilize the high power computing systems. The need for high power computing systems can be felt in this manner that for better estimation of the cyclone genesis, intensity and movement, you need as dense as possible the observations to feed into the computing system, so that you will have the better estimation of the initial state.
Very interesting. Very interesting. We'll continue this conversation, but we'll take a very small break. Welcome to this episode of Eureka. We are having a very interesting conversation with Dr. Mrutyunjay Mohapatra, who is heading the Cyclone Warning Center of India Meteorological Department. We are talking about forecasting cyclone. Although we cannot predict it exactly, like for example, celestial phenomena like let's say eclipse, but you say that we can do a reasonable forecasting, and then you are using a lot of tools. You are explaining that. Can you throw more light on it?
Yeah, I was just telling that the prediction of cyclone starts with the detection of the cyclones based on the latest tools and technology to observe it. So at present, we utilize all the observations with the help of the satellites, radars, automated weather stations, observations from the floating buoys over the sea surface, and scatterometer observations from the sea surface, and also the coastal and island stations data. So all these observations are fed into a high power computing systems in a digital format to simulate the initial condition of the ocean, atmosphere, and the land. Once that is done, with the application of the specified physics of the cyclones, these equations lead to the solutions and the forecast for different time intervals like 12 hours, 24 hours, or up to say 5 days. At present, as per the current state of art in the world, the cyclone track and intensity forecast is provided up to 5 days.
Up to 5 days, you can kind of get a reasonable prediction about the forecast about what will be the path a cyclone will take.
Yes.
Okay.
Up to 5 days, we provide not only the likely track or path of the cyclones, also we provide the point where it will hit the coast, at what time it will hit the coast, and we provide what will the intensity at different time intervals and at the time of landfall of the cyclones, and also we provide what will be the expected weather like heavy rainfall, its time of occurrence and its duration, and the area of occurrence. Similarly, wind speed, that is gale wind speed, which is a damaging wind speed, the time of occurrence, area of occurrence, and duration of occurrence. And also we provide the most important, which is called as the killer of the cyclone, that is the tidal wave, or popularly called as storm surge. That forecast is also generated, and it indicates what will be the height of the tidal wave at the time of landfall of the cyclones, what will be the area of inundations, how much duration this tidal wave will continue. So all these are also predicted well in advance.
Well in advance. Very good. Before the break, I was saying that a school teacher wrote a poem about you while you were studying in your primary school. What is this incident?
Actually, it is not that while I was studying primary school, but when I was just in this India Meteorological Department, one primary school teacher wrote a poem on me, highlighting that in future I will do something good for the country.
Okay, very interesting. And I believe your interest in cyclone started when you were a 7-year-old kid. So about that 1971.
So I was 6 years old when I was not knowing what a cyclone is. We just got some information that there is heavy rain, winds, etc. It was devastating our area. In the morning of 29 October 1971, if I correctly remember, we were all taking together the breakfast in our house. My father went outside for lecturing purpose. And he immediately rushed back to our house, and instead of coming to inside, from the window itself, he knocked us and told that all of you should go off, and that is a mud house in our house, where there is some kind of second floor where people can stay. So therefore, immediately with a ladder we went off, and my father was a ward member. So at that time there was no such early warning system. But he himself took the initiative, and he went door to door and informed everybody to come to our house. And you cannot imagine, about 300 people were taking shelter in that mud house, where there was a provision to stay on the first floor. So at the evening we all came back. At that time it is completely devastated. There was nothing. So my auntie prepared some food with the rice and drumstick leaves. There was nothing else. So that was the first you can say misery of the cyclone which we assessed ourselves.
Very interesting. Just as a 6-year-old kid, you experienced cyclone and its devastating power, and that perhaps inspired you to, save lives of others. And I'm told in your department, you have kept pictures of damages caused by cyclone, so that all of you, whenever you come to office, feel that you are doing a very important work. Can you tell us something about it?
Yeah. So, as the head of the cyclone warning division, it is my responsibility to motivate the colleagues to act vigorously during the cyclone warning situations, because it is a warlike situation when there is a cyclone over the Bay of Bengal or Arabian Sea. Every 3 hours we issue the bulletins. So, it is the motivation of the people which lead them to work day and night to provide the service to the country. So, for that purpose, if you cannot feel what is the misery of the cyclones, perhaps you will not be motivated. So, therefore, in the cyclone warning division itself, we have kept the historical damage photographs, loss of lives, so that people can remember that each and every step by them during cycloning process is going to help the common mass to minimize the loss of life and property.
Very interesting, very interesting. We'll have to take a small break here. Don't go away. We'll take a very small break, and then we are going to have a very interesting discussion. Do you know, when a cyclone pollen hit India, IMD predicted exactly the precise point in which it's going to cross. And the predictions differed from the US predictions, and people were wondering who will be right. We are going to talk about this and more after the break. Don't go away. Keep watching Eureka. Welcome back to Eureka, and we are having a very interesting discussion with Dr. Mrutyunjay Mohapatra, who is the head of Cyclone Warning Center of India Meteorological Department. Your name itself is Mrutyunjay, and you have saved a lot of life. In 1999, when the super cyclone hit Orissa, more than 1 lakh people died. And then when in 2013, pollen hit, the numbers were terribly small, thankfully. And that's because of the good work done by the India Meteorological Department. In 1999, you were in Orissa, and 2013, you were heading the Cyclone Warning Center. How did you feel in those 2 times? What happened actually?
Yeah. As the law could have it, actually, I joined IMD in 1992, and in 1998, I was posted as a meteorologist in Meteorological Center, Bhubaneswar. And in 1999, there was super cyclone. So, while dealing with Odisha super cyclone, the 1971 cyclone was in my background. I was always remembering what the devastation has been by myself and the society in 1971. So, I was very much eager to deal with better with available tools and technology with the Odisha super cyclone 99. But however, considering the state of art of technology at that time, considering the socio-economic condition at that time, India Meteorological Department could provide forecast only 24 hours in advance, telling that cyclone is coming to cross Paradip coast. And we could not predict the intensity of the cyclone properly. There was lack of consistency in the cyclones. So therefore, when you don't have the more accurate forecast, you don't have the consistent forecast, and you don't have the timely forecast, the disaster managers cannot believe upon you to take the timely actions. As a result, only about 44,000 people were evacuated from Paradip coast. And all of us know about 10,000 people died during Odisha super cyclone. So I was just looking at as helpless, because by this time, unlike 1971, I was knowing what a cyclone is, what are the misery associated with cyclones, what are the disasters weather associated with cyclones. I was trying my best to provide, but however, I was handicapped due to lack of tools and technology and the observational systems. At that time, in 99, we did not have any radar. We have the cyclone detection radars, which is analog type, but Doppler weather radar is very much helpful in determining the location, intensity, and associated weather, etc. Similarly, we did not have at that time any automated weather stations. We have only one satellite at that time, which is providing the pictures, not many derived products as we have today. So there was limitation with respect to the observational aspects.
Okay, here let me ask one question. At that time, what was the kind of observational infrastructure is we had, and what is the thing that we have now? If you compare, how do you put them at?
So if I compare, actually there has been a paradigm shift with respect to all approaches of the cyclone warning system, with respect to observations, with respect to modeling, with respect to communication, warning generation and disseminations. To begin with, if you consider the observations, at that time we have only one satellite INSAT. Now we have got 3 satellites. We have got INSAT 3A, INSAT 3D, Kalpana, and INSAT 3DR has been launched now also.
So which means that at that time you can get a picture for, let's say, once in half an hour. Now you can get a picture about once in 15 minutes.
Every 15 minutes we have now the pictures because of
so
the
that's
multiple
about
satellites.
satellites.
Yes. Similarly, at that time there was no cyclone detection radar which are of digital type, that is Doppler radars. We have got now 24 Doppler radars in the entire country, and all the entire coast of east and west coast of India are covered by the Doppler radars. So
and weather stations?
At that time, actually, there was no automated weather stations. Now we have got about 675 automated weather stations, in addition to 550 manned weather stations. Similarly,
so something like from about 500 to about 1,300 is the increase, right?
Yes. Similarly, there was no automated rain gauges. Now we have got 1,350 automated rain gauges in the country. So what happens actually, these automated stations can provide you the information every hour, whereas the manned stations provide information every 3 hours or sometimes every 12 hours. In addition to that, the sea surface, which are data sparse, now it has been filled up with the launching of buoys, meteorological buoys by Minister of Earth Sciences. We have got around 20 buoys over Bay of Bengal and Arabian Sea. It was not there in 99. And in addition to that, Minister of Earth Sciences have also deployed about 20 ships equipped with automated weather stations along the coastal areas. So these are the improvement in the observations.
So all this would have costed huge amount of money, right?
Yeah, it has costed huge amount of money. To cap it all, India Meteorological Department took off a modernization program in 2007, which was with an investment of 437 crores.
437 crores. Okay. In terms of return, what would you say?
So if you just compare that, of course, that 437 crores includes not only the observations, it includes the upgradation of the computing system. We went for the high power computing system, we went for the numerical modeling systems. These are the structural. In non-structural way, we went for the collaborations with national and international partners. So as a result, if you find out, compared to 1999 when 10,000 people died because of the Odisha super cyclone, with the similar cyclone of Cyclone Cyclone on 12 October 2013, which crossed Gopalpur, only about 20 people died. In financial term, you cannot measure the life of the people, but however, if I just compare 2 figures, say cost of ex gratia paid by the government to the kith and kin of the survived, then if you take 6 lakh rupees, for example, for head payment, and 10,000 people payment in 99 and 20 people payment in 2013, it comes about 500 crores saving of the exchequer.
So just in this one cyclone, by saving people, all the investment has been returned.
Entire investment.
So investing in science not only saves life, but also saves money.
So you correctly told. Entire investment has been reimbursed by one cyclone. And if you consider, there are 5 cyclones developing over the area every year. So therefore, you can just imagine only because of cyclone how much has been the saving to the property and money. In addition to that, all these investment not only helped in better monitoring of the cyclones, also other severe weather events.
Very interesting. There was also this day before the pollen crossed Gopalpur. You had a sleepless night. Why was it?
Yeah, Cyclone was very challenging. We predicted Cyclone on 8th October itself that it will cross Gopalpur coast with a wind speed of about 220 kilometers. And from that day onwards, as you know, there are many agencies in the globe now to provide the forecast. Certain agencies were predicting that it will cross as a super cyclone with a speed of about 300 to 320 kilometers per hour. So we were under pressure. As a forecaster or the chief of the cyclone warning division, I was under pressure whether to be consistent with my forecast or to succumb to the pressure and change my forecast to go with the forecast of USA or some other agencies. But we kept our nerves, we maintained our forecast, and finally it so happened that we went correct and other agencies went wrong.
Very interesting. If I again want to have a small comparison, let's say the super cyclone of Orissa, which is a, in some sense important landmark, and the pollen or current situation. How do you say is our resolution power of predicting cyclone path and various other parameters?
Yeah. So if I just compare, at that time the forecast was very qualitative. There was no objective forecast telling where the cyclone will be, what will be its latitude, what will be its longitude, what will be its intensity. That type of forecast was not there at that time. It was a very qualitative forecast, subjective forecast. Once this forecast is not objective, it is very difficult to act upon. Whereas in Phylon case, the forecast was 120 hours, that means 5 days forecast with 2 days outlook. So total 7 days forecast about the genesis and track, etc. This is number one. Then number two was in terms of the accuracy. At that time, as there was no subjective forecast, there was no verification of the forecast. We introduced verification of forecast, and forecast accuracy, if you remember, it was almost zero error in case of Phylon. About 5 days in advance, we told Gopalpur, and it crossed Gopalpur. Winds were 220, it became 220. But however, if you just compare the average forecast error, taking different cyclones in the recent 5 years and compare to previous 5 years, there has been almost 50 to 60% improvement in accuracy or the skill of the forecast. At present, if I just consider what is the landfall point forecast, around 2003, it was about 150 to 200 kilometers error in predicting the point of landfall of the cyclones. Whereas at present, in 24 hours, forecast error is about 50 kilometers.
Very interesting. So earlier we were able to say that maybe somewhere in this 150 kilometer the cyclone will come. Now we can give it in 15 kilometers. It's a very interesting point with this.
It has certain interpretation like this. If I say my forecast that cyclone will cross the point X, and people know, because we inform our accuracy to government and disaster managers, people know that my error is 150 kilometers, then government will prepare to evacuate people 150 kilometers to the left, 150 kilometers to the right, so total 300 kilometer evacuation will be required. Whereas at present, when my forecast accuracy is 50 kilometers, government will go for evacuating people only 50 kilometers to the left and 50 kilometers to the right. So as a result, you are reducing the area of evacuation from 300 kilometer to 100 kilometer. And if I give an example, what is the cost towards evacuation? Because when you evacuate people, you have to go to the shelters, you have to give the food, you have to give the water, etc. So cost evacuation, if you just compare, 1 kilometer evacuation cost about $1 million in USA. So if you take 1 million rupees in India, you can just imagine what is the advantage.
Very interesting. And we are having a very, very interesting conversation, but unfortunately, for lack of time, we need to conclude here. But I think one interesting point that comes out of this conversation is invest in science. Invest in science, our Indian system can deliver. That's a proof that we have with your conversation today. And thank you for being with us. It was a very enjoyable conversation and very illuminating conversation. Thank you. Keep watching Eureka. We'll meet in the next episode with an interesting conversation with another scientist.